So 6.6, hinge theorem. This is the main idea behind 6.6 is the hinge theorem. Yesterday, or in 6.5, we talked about comparing side lengths and angle measures inside of one triangle. For hinge theorem, now we are comparing in two triangles. We're comparing between two triangles. And the only time that we can do this, the only time that we can use this hinge theorem is when we have two pairs of congruent sides. Okay, we need two pairs of congruent sides between those triangles to be able to compare them. If we don't have that setup, we cannot use hinge theorem. Okay, you have to have two pairs of congruent sides first. Otherwise, we can't do it. Okay, so we've got two pairs of congruent sides. And what this is saying is, if we have that, then we can look at the included angle. Included angle we know is the angle between those two sides. So if we have two pairs of congruent sides, we look at the included angle. The bigger the included angle, the bigger the third side is going to be. So since 88 is bigger than 35, I know this third side is going to be bigger than this third side. Which, of course, is obvious when you look at it, right? Because we know that one's longer, but this is why, okay? It's the hinge theorem. Tells us for sure that because this is bigger than 35, this side is bigger than this side, okay? That's what we're looking at for. Let's think about, I gotta take my camera with me, I'm not used to this. We're going on a field trip, kids. We're gonna look back here. See if I can make this work. Don't fall off the table. All right, so this is a hinge, right? Hinge of a door. This is why it's called hinge theorem, okay? Because it's a hinge of a door. If I have two of these open, okay? I've got two pairs of congruent sides. I'm thinking of the sides as being the door and then this opening right here. Okay, the door and this opening are the same for both of them. Door, opening. The bigger my angle, the bigger my hinge, the bigger the opening. The bigger the opening here, right? The smaller my hinge, the smaller the opening of the door. That's why it's called hinge theorem, okay? Because it acts like the hinge of a door. The bigger the hinge, the bigger the opening. Smaller the hinge, smaller the opening. But that door and this have to be that same size, okay? You have to have that two pairs of congruent sides first for that to work, okay? All right, let's head back. Don't get dizzy as I walk around now. All right. Any questions on hinge theory? Good?
If it was the door, wouldn't the two sides on one triangle be the same?
So in terms of the door, like this would be the door itself. And then this was the part attached to the cabinet, like where my stuff was, right? And this is the opening of the door, okay? And then our hinge is right here. This is the hinge. So we open it more, we have a bigger opening, we close it smaller. All right, so we've got that. The converse is also true. So we have a converse of the hinge theorem as well. The same setup has to be there though. Okay, the same setup is there where we've got two pairs of congruent sides. So still two pairs of congruent sides. That does not change. The setup is the exact same. The difference here is now we know information about the third side. We know the lengths of the third side. Now we can say something about that included angle. So that's where the converse comes in. That's the opposite that we're talking about. Two pairs of congruent sides. The third side is bigger. The hinge is going to be bigger. That third side is smaller. The hinge is smaller. All right, that's our converse of hinge theorem. And it is important to know the difference between these two. You are actually going to run into a proof today for the first time in a long time. I think there's just one though. So make sure you know the difference between hinge and converse of hinge. Okay? Hinge theorem, we know the hinge. We know the angle. Converse of hinge, we know the opening. We're looking for the hinge. I think I used the word hinge more in one lesson in this book than the rest of the year combined in my book. So hinge theorem, converse of hinge theorem. Any questions on those two? Okay. So we're going to see some basic questions, right? Something like this, where it's saying, how does JM compare to LM? So first we got to make sure we have the setup, right? We got to make sure we have that set up. 2 pairs of congruent sides. Do I have 2 pairs of congruent sides? Yeah, I've got reflexive property, right? Reflexive property, KM and KM are congruent. Those are congruent. I've got the 2 pairs of congruent sides. So now I can look at my hinge, my included angle. This one's bigger than this, so JM has to be bigger than LM. That's all they're going to ask for, right? They're going to ask you to type in the correct sign or pick the right symbol or whatever. Which is bigger than? Same idea, but with the converse would look like this. And now they'd be asking us to compare this angle and this angle. Again, we have reflexive property, so we have 2 pairs of congruent sides. Okay, reflexive property, so 2 pairs of congruent sides. We've got our included angles are the ones we're looking at. Here, 24 is bigger than 23. So this angle would have to be bigger than this angle. So TSP would be bigger than RPS. Okay. Good. See what else we have here. All right. Got a word problem here that we got to look at. So I want you to take a couple minutes to think about this. I want you to sketch something out, do whatever you need to. They're giving us 2 groups of bikers, leave the same camp heading in opposite directions, so I would sketch it out. They travel 2 miles, then change direction, travel 1.2 miles. They tell you about group A, group B. We want to know which group is further away from the camp and be able to tell us why. Okay, so I'm going to give you a minute or 2 here. I want you to sketch it out and see if you can figure out which group is further away from camp. obviously we're gonna be using hinge theorem or converse of hinge theorem here. That's what we're talking about today. So figure out based on your drawing and the hinge theorem or the converse of hinge theorem, which is gonna be further away. Give me about 30 more seconds here, and I'll draw it up and we'll talk about it. So before I draw it up and I start talking about it, what do we think? Group A or group B? B? A?
Oh, no, wait, never mind.
Any guesses? People at home, what do you think? A, B?
I think A.
Think A?
A.
A? All right.
B.
B? All right. We got both sides here. Let's take a look. So here's Cam. We got two groups going. All right. It tells us group A starts due east. So we're going to call that this direction. And remember, they travel 2 miles to begin with. So group A is going this way. Group B is going this way. They're both going 2 miles.
It actually never said which direction they started heading to begin with.
It actually did. Group A starts due east.
Oh.
Group B starts due west. It didn't at the beginning, but it did later on. So there you go, A and B. So group A starts due east and then turns 45 degrees toward north. And this is where we tend to make the mistake. 45 degrees towards the north. They are heading in this direction right now. They're heading this way. So then they go 45 degrees towards the north. They're turning here. This is the 45 degrees. Some of you guys did this as 45 degrees. Okay, they're heading in this direction. So they're going this direction, and then they had 45 degrees towards the north. They're heading now this direction for 1.2. So they're heading in that direction. This is the 45 right here. Okay, group B, due west, and then turns 30 degrees towards the south. They're heading this direction right now. So when they go 30 degrees towards the south, they're turning here. So they're turning 30 degrees towards the south here. 1.2. Okay, so this is the setup. That 30 degrees is this way. So it might look slightly different than what you have drawn. Typically, people draw that 30 degrees towards the south this way, because they feel more comfortable with acute triangles rather than obtuse triangles or something like that. So now if we're thinking about how far away they are from camp, all right, we've got these are congruent, these are congruent. So we look at our included angle, our hinge here is 180 minus 45. So our hinge here is 135. Our hinge here is going to be 150. So this one's bigger. So this side is bigger. So group B is further away from camp. And again, it's all in the way that we draw it out. We drew it the other way, right? If we thought about it as going up 45 here and down 30 here, then yes, A would have been the answer, but that's not what they're saying. So just wanted to point that one out so that we can get it correct the next time that we see something like that. Good?
Will it be on the text?
It might be. I don't think so, but it's a possibility. Yeah. All right. Any other questions on that one? I've got one more thing to look at here. All right, we're going to look at 21. I'll rub it up right here. looking at 21. And what we want is a range of answers for x. What could x possibly be here? That's what we want to know. Okay, we have two pairs of congruent sides here using reflexive property. I've got here and here, here and here. Okay, this tick mark is going to come into play later. But I've got two pairs of congruent sides here. When we look at it, we can tell, and we can do some assuming here, which one of these angles is bigger, left or right? Left. We know the left one's bigger, right? So if this left angle is bigger, that means this side has to be bigger. This side has to be bigger than this side. Since these are congruent, that means this is also 2x. Right? If this is 2x, that's 2x. So using that hinge theorem, I know this is bigger, so this side has to be bigger. So I would set up my inequality, 4x minus 3 is bigger than 2x. Okay, so that's our inequality. I know that has to hold true. But what else do I know about 2x? What else has to be true about 2x here? Haley?
Would you add them together and it has to be greater than 2x?
Nope, not necessarily. Nope, we're not going into the stuff from yesterday. Okay. But any side of a triangle, this just does not want to let her in. Any side of a triangle has to have a length, right? Can it have a negative length?
No.
No. Can it have a 0 length? No. So I know that 2x needs to be bigger than 0. Right? It has to have some length to it. Now you could have split these up into two separate, where I have that inequality, and then separately I have 2x is bigger than 0. That's fine. Or we can have it together. Okay, but we know this has to hold true. Let's do it separate. I think that's sometimes easier to think of it separately. So I know 4x minus 3 has to be bigger than 2x. I solve that one out. I subtract 2x. I add the 3. I know x has to be bigger than 3 halves. Right? If I solve this one out, x has to be bigger than 0. Well, they both have to be true, right? So if it's bigger than 3 halves, it automatically has to be bigger than 0. This is just a check. This is a check to make sure, yep, it can't be negative, okay? This is where your main answer is going to come. This is a check to say, hey, does it make sense? Right? Because if we're going to plug a number in and it gives us a negative side, that doesn't make sense. Here, no matter what I plug in that's bigger than 1.5, it's going to make sense. It's going to be positive. So we're okay with just this as our answer. Okay? There are going to be times where you're going to have to do both of these. And both of them are going to come into play in the answer. So just know, if you're looking for that second part, if it's asking for 2 answers and you have no clue why, it's because that side has to be bigger than 0. Okay? So I just want to show you that even though we didn't use that for our answer here, we are going to come in contact with some problems where we do need to do that. Okay. All right. Any questions about this or about hinge theorem or converse of hinge theorem? Yeah.
Would 0 always be one of the answers?
It depends on what this is, right? Because if this is 2x plus 3, then now it's not 0, it's a negative 3. Okay. So yeah, it all depends on what that expression is going to be. Anything else on this section? Nope. Stop my recording.